Hi everyone, this video is going to be on using a factor tree to find the cube root of a number. In our last video we used a factor tree to find the square root of a number, and in this video we're going to now cube root a number. A very similar process to what we did before, but this time around we'll be discussing what is the cube root of a number. So hopefully you understand what a cube root of a number is, but if not, I'll quickly go through it here. This little sign here, just pay attention to the fact that with a cube root sign you will have that little 3. Okay, with the square root sign we don't have a little number, but for cube roots and any root above, so 4th roots, 5th roots, 6th roots and so on, you will have that little number there. And the cube root is the opposite of cubing. They're inverse operations, and when we cube a number, we take a number and we multiply it by itself 3 times. So we'll take a number, multiply it by itself, and then multiply it by itself again. But when we cube root, we're thinking, what is that number that I multiplied by itself 3 times to get 27? And once again, it does pay to know your times tables. Hopefully you'll know that if I take 3 and times it by 3, and times it by 3 again, 3 3s are 9, 9 3s are 27. So the cube root of 27 is 3. So we're thinking, when we did square roots, we only thought of a number that times by itself to give me the number under the square root sign. With a cube root, the number has to be multiplied by itself 3 times. I've chosen 64 over here, the cube root of 64, because I like 64 because you can square root it and cube root it, and I think that's quite snazzy that you can do that. So what's a number that you multiply by itself 3 times to give me 64? Hopefully you know some of your cube roots already, that if I take 4 times by itself, I get 16, and 16 times 4 is 64. So that means the cube root of 64 is 4. So 4 cubed, here I've got 4 cubed, equals 64. But the cube root of 64, that takes me backwards again, or reverses the process, and that asks me what number do I multiply by itself 3 times? That is 4. So that begs the question of what do I do for really large numbers? I have no idea what the cube root of, oops, that should be a cube root sign. I'll put the little cube root in there. What is the cube root of 3,375? I do not know. So that's where we're going to use our factor tree. So we can see here straight away, I noticed that this number that we're trying to cube root, it ends in 75. So that tells me that not only does 5 go into it, but I'm guessing that 25 goes into 3,375. Hopefully your long division is pretty good. So let's divide it through. 25 goes into 33 once, leaves a remainder of 8. And I'll bring down my 7. 25 goes into 87. I know 25 times 3 is 75. So if I put the 75 down, that gives me a remainder of 12. Bring down the 5. And I know that 25 times 4 is 100. So that means 25 times 5 would be 125. So it turns out that 25 times 135 is 3,375. And you could have divided by 5 and gotten different factors. It really is up to you where you want to begin. Okay, so sorry, let me just get rid of this 25. It's very hard to understand. Alright, so we can easily break 25 down into prime factors, so that's handy. That's done, but we need to think about 135. So let me get 135. We know it's divisible by 5, so let's divide the 5 in. 5 goes into 13 twice, remainder 3, and 5 goes into 35 7 times. So we've got here 5 times 27. So I'm getting close now. I've got another prime factor of 5. And then I'm going to go a little bit further and break 27 into 9 times 3. I'm nearly there. I've got one more prime factor of 3. And now I'm going to break 9 into 3 times 3. So I'm now down to all my prime factors. Prime factor, prime factor, prime factor, prime factor. I'm losing prime factors. Don't ask me why. Let's get that 3 back there. 3 times 3. Alright, when I was doing my last video and we were trying to square root a number, I needed to think of a number multiplied by itself. This time around with cube root, we need a number times by itself again. So when I take the prime factors at the bottom of my factor tree, I'm going to split them 3 ways. So I'm going to put 1 5 here, second 5 there, and a third 5 here. So I get the same number in each circle. And then I've got 3. Remember, all these prime factors are connected by multiplication. So I'm going to take 1 3, put it here, a second 3, put that here, and my last 3, and put it over here. So now I know what number multiplied by itself 3 times gives me 3,375. It's 5 times 3. And what that means is that the cube root of 3,375 is that number there. Whoops. Sorry. This number here, which is 5 times 3, which is 15. So the cube root of 3,375 is 15. Hopefully that made sense to you. The numbers are a bit bigger, so the arithmetic is a bit heavier. We'll look at one more example just to help you out and make sure you understand. If you are happy and feeling confident, then pause the video and find me the cube root of 5,832 and then check it with my video or with the solution that's coming up. So we need a number that goes into 5,832, and we can see 32 is divisible by 4, so let's divide by 4. So 4 goes into 5 once, remainder 1, into 18 4 times, remainder 2, into 23 5 times, remainder 3, and into 32 8 times. So we've got 4 times 1,400 and, sorry, my writing is terrible, 58. Bear with me here. Okay. And I can see already just by looking at that last digit of 8 that I can go again and divide 1,458 by 4. So 4 goes into 14 3 times, remainder 2. 4 into 25 goes 6 times. Isn't that interesting? It doesn't divide. I should use my divisibility test. We need to come up with another number that I can divide it through. I'm going to try, if I look at the digits of 1,458 and add them all together, I can see that I get 4 plus 1 plus 5 plus 8. That's 18, which is a multiple of 6. So I'm going to try 6. 6 goes into 14 2 times, remainder 2. 6 goes into 25 4 times, remainder 1. And 6 goes into 18 3 times. So it turns out that 1,458 is 6 times 243. Let me clear some space for myself so I can do some more dividing. So now I'm getting closer. I can break 4 down into 2 prime factors, 2 times 2, and 6 I can break down into 2 prime factors of 2 times 3, and now all I'm left to deal with is 243. Well, 243, I already know 2 numbers that multiply to give 243. If you don't, let's try 3, last digit. 3 into 24 goes 8 times, and 3 into 3 goes 1. So we've got here 3 times 81, and now we know we're really close because 81 is just 9 times 9. I go a little bit further and break that into 1, 2, 3, 4 3s. Okay, so the factor tree went for a while. I've got all my prime factors, and if I'm having trouble seeing them because the factor tree got quite long, then I'm just going to highlight them. Okay, I might change my color pen so it stands out. I need to think of a number that multiplied by itself and then again, so 3 times gives me 5,832. So I'm going to put 1 2 here, second 2 here, and a third 2 here. Then I've got my 3s. I can put 1 3, here, second 3 here, and a third 3 over here. And then as you can see, I've got 3 3s left just here. So I've run out of room. So I'm going to put one of those 3s here, a second 3 here, and my last 3 here. And I think it's obvious, but if you have any leftover numbers and you can't split them 3 ways, then you've made a mistake, because to cube root a number, it needs to be able to be broken into one number times by itself again, and there should be no more prime factors left. So now we can see that there is a number that multiplied by itself 3 times gives me 5,832, and so the cube root, a little 3 there for cube root, of 5,832 will be this number here, 2 times 3 times 3. Well, 2 3s are 6, and 6 3s are 18. So that is the cube root of 5,832.